everyone, Katrina here. Today I'm going to clear up some confusion about what the remainder theorem is and what the factoring theorem is. So let's consider a higher order polynomial equation. In this case, we're going to consider a cubic equation because the highest degree of this polynomial is degree 3. So given that we have some cubic polynomial written in this form, let's look at what the remainder theorem says. It tells us that if f of x, our polynomial, is divided by x minus n, then the remainder is f of n. So say, for example, we wanted to check what is the remainder of our function if we divide this by x minus 2. That means that we would then plug in this 2 into our polynomial, so we would have f of 2, and that there would be our remainder. So what happens if this remainder equals to 0? So if this remainder equals to 0, then that actually is a perfect segue into our factor theorem. So our factor theorem tells us that if f of x is a polynomial and f of n equals to 0, then then x minus n is a factor. And this is true in reverse. So if x minus n is a factor, then f of n equals to 0. So this shows how the remainder theorem and the factor theorem work together. So if we first use the remainder theorem and we see that we get a remainder of 0, that means that we can then apply the factor theorem, and that will tell us what the factors of our polynomial are. So in this example over here, if we get that f of 2 equals to 0, that means that this value over here, x minus 2, is a factor of our polynomial. Once we have this factor, we can then go on to perform synthetic division in order to factor the rest of our polynomial. Those skills are shown in my other video, so be sure to watch those. If you found this interesting and insightful, please drop a like and comment any questions that you have. Subscribe for more fun, exciting, and entertaining math videos. I'll see you next time.